All right, good evening, everyone. Time for the last session before our closing session with Bart de Smet. Everything seems to run fine from our side, but don't forget to rate the sessions you're attending. We also love your feedback about this new virtual experience. So back to work now, and time for a session with Peter the Tender. Peter will try to serve you the container alphabet soup: ACR, ACI, ACS, AKS, DCK, and what's more. Enjoy.
Thank you for the nice introduction. To my audience, welcome. And yeah, we know it's all virtual, but I'm going to try to keep it as entertaining as possible. Now, based on, I would say, the local time here in Belgium, depending from where you're connecting in the world. But for us, it's like a little bit after 6 in the evening, which means that probably your stomach starts running around a little bit like, I need some food. And that was mainly the topic for my session, where I'm going to try and help you a little bit in understanding the different Azure Container related acronyms. So feel free to ask any questions in the chat box or in the Q&A option. I also have some Q&A time all the way at the end. And in between, I'm going to walk about what are containers, for as far as you don't know what containers are at least, how you can move from a traditional application into container workloads, where it's going to be, I would say, quite quick, because the core is not training you on containers, but it's about the third topic here, how to run your containers on Azure. And once you have them running, how can you optimize them? Meaning making them more high available, running them faster, and maybe even doing some advanced configurations options in there. And then all the way at the end, Q&A. So I should have about 50 minutes of content, depending on how interactive you want to make this. But we'll see how it goes. So first of all, one word of thanks to all the sponsors here. Although it's virtual, there's still quite a lot of logistics involved, some cost for keeping everything up and running. And as you all know, without these sponsors, this event wouldn't even be possible. So make sure you reach out to them. If you know anyone who's working for any of the partners, let them know how thankful you are in supporting us in providing this online conference and all the other ones that's happening out of the VISUG user group. So for the ones who don't know too much about me, so I'm Peter, based out of Belgium, specifically now with the whole COVID situation, like I guess most of you. But before COVID, I was actually not that much in Belgium, like maybe 30 to 50 days a year. And as a profession, I was running my own business for the last 10 years. Before that, worked for a couple of different partners in Belgium as an overall Microsoft consultant. And about 10 years back, I started my own business with a focus on readiness, initially on Microsoft on-prem solutions. And obviously, thanks to cloud, running your own business, you need to move to something new. And that's what landed me into Azure. And since a bit more than a year now, moved to Microsoft as a FTE and still providing Azure readiness workshops all over the world, which is partly possible thanks to COVID. If we need to tell something positive about it, if that's even possible, then I think that's one of the most interesting ones. So feel free to stay in touch. I'm all over the place, LinkedIn, Facebook. I'm not on Instagram or Snapchat. I guess I'm getting a bit too old for that. And everything that I'm going to try and push through in the next 55 minutes is also available in a couple of online books that you can find on the traditional book web shops. So the topic is trying to find, I would say, the specifics around containers on one side and how we can run them in the Azure platform in a couple of different ways, where it's not really about the acronyms itself. It's mainly about clarifying, first of all, like, what is a container and why should we use it? And then from there, moving on to running this container in Azure and what are the different services that could help me with that. Now, why are containers so interesting today and where do they fit in our data center landscape? It's really about what even Gartner calls the digital transformation, or what I call the journey to the cloud, where you could start on the left-hand side with traditional virtual machines. That's what you're running today in your on-prem data center, maybe a hosting environment. And from there, you're going to move to the cloud, and that's what we call rehosting, where you're going to pick up what you have, lift and shift, moving it, running it in a cloud environment, but not really changing too much. It's not super efficient. It's a little bit expensive. So we're moving on to some cooler workloads. All the way on the other side, we have SaaS, so software as a service, where I guess most of the attendees here are coming from the development world. So you're going to build your applications, web apps, API apps, maybe moving into a serverless architecture like Azure Functions, Logic Apps, Power Automate, maybe from the Office 365 angle. And then somewhere in the middle, that's where we find containers. Now, what we're going to do with containers is somehow still leaning more to the traditional way of running applications, but it's not depending on virtual machines anymore. So if you have no idea what a container exactly is, it's almost identical, I would say, in concept to a virtual machine, where on the left-hand side, it's a rough architecture of a virtual machine, where most important, we start with the physical layer in your own data center or like an Azure data center, but obviously then you cannot really touch the physical components. On top of that, you have the host operating system and the hypervisor, which would be Hyper-V, VMware, and maybe some other brands that are less important these days. On top of that, you're going to deploy a virtual machine, which is a collection of a full-blown guest operating system, Windows or Linux, with a whole bunch of flavors. Within, you're going to deploy binaries, libraries, think of .NET, maybe Java apps, Node apps, or anything else, and deploying your application footprint, which in case of a web application, that's what I'm going to use for most of my demos. You're going to run a .NET application, which means you install Windows Server, or maybe Linux these days also works. You install the .NET framework, and from there you install IIS, and your web app is running. Or it could be SQL Server, that's the second dependency on my application workload, deploying a Windows or Linux again, running SQL, MySQL, or any other database format. Now, moving this exact same workload into containers means that it's, again, slightly similar, but also slightly different. The most important aspect that's different is that we're not running a full-blown operating system, but we're going to provide some kind of kernel. So within a container, like a standalone isolated environment, you're going to host your application that's depending on the same binaries as before in the VM world. But the intelligence, like what makes my container image running, would be the Docker engine. Now, Docker is not the only one. We do have a few other ones, but I think I can say, that Docker is really the standard. So the focus is on virtualizing your application, but this time not really running on top of a virtual machine anymore, but moving it into this isolated environment. Now, once you have your container, and I'll walk you through some scenarios how you can create a container. Now, once you have your container, you're going to run it on top of, in this case, the Azure platform, with a whole bunch of options, and I'll try to cover at least 3 of them in the remaining part of the session. So you have container instance. It's probably one of the easiest ones. You provide a container image, you upload it into Azure, and from there you're going to start up the container and it's running. Or you could move to a more advanced scenario, a little bit more complex, but also giving you better high availability, better uptime, more management options by, for example, running Azure App Services. Now, you might know App Services for running your web applications where you have source code. And now you can use the exact same characteristics, all capabilities from App Services that you might know, but instead of pushing source code, you're going to publish your container. Or partner ecosystem, if you're familiar with Docker Swarm, if you're familiar with Docker Enterprise, maybe you're familiar with Red Hat OpenShift. So that's where partners are adopting the container footprint and building a container runtime on top of that. So a lot of different options, and that's where the I would say that the alphabet soup comes from. So we got ACI for Container Instance, ACR for Azure Container Registry. We got DCK that would refer to Docker. We have AKS for Azure Kubernetes Service, and that's where it becomes a little bit complicated. So the first part is, where do you get started? Now, since we have our application footprint, it means that we're going to build our Docker container. Now, what is Docker? I'm not going to spend too much time on Docker itself. I assume that you already know what Docker is and how you can use it. But Docker is partly the company behind the intelligence, the software, the tooling that provides you that open source containerization platform. Now, it's not 100% open source. What it means is that you can, as for example, a developer, you can install Docker desktop on top of a Windows machine. That's what I'm using for my scenarios here. It runs on Mac, runs on Linux. It runs on top of a Linux server operating system. And you could also install Docker Enterprise Edition, which comes with a fee, to run it on top of a Windows server operating system. And if you think back about that architectural diagram in, I don't know, slide 4 or slide 6, that's really that in-between intelligence between your host operating system, the physical or virtual environment, and the containers you're going to run on top of that. From there, it's natively supported in Azure. So all the services that I'll briefly touched on, and I'll walk you through in some other demos, are natively supporting Azure, which also means that you don't need to change anything to the container to keep it or make it running on Azure. Outside of Azure itself, obviously, container is multi-platform ready. So if you have on-prem virtual machines, physical servers, as long as you install that Docker daemon or the Docker engine, in between, it's going to run fine. If you run your containers on Azure, perfectly fine. If you run them on AWS, on Google Cloud, or anywhere else, as long as they're recognizing the Docker engine, it means that you can run your containers all over the place. And then last, although containers are typically popular for Linux-based workloads, nothing would stop you in meantime to also deploy Windows containers. The main reason why you would deploy Windows, full-blown Windows containers is, for example, for the full .NET framework, where if you use .NET Core, although it runs on Windows, could also run on Linux, Java apps, Node apps, or any of the other language frameworks that you might work with are probably running on top of Linux anyway. Now, the management is mainly Docker command line based. So what you're going to do is installing Docker on your local machine. So let's say you're the developer or maybe sysadmin and you want to test out some Docker integration. You're going to start with your operating system, turning it into a Docker host by installing the Docker desktop. So on my machine, it's this little wheel up here, and there should be some settings visible. Come on, Docker, you can do this. Oh, there they are. Good. So you can define that you want to run Docker desktop whenever you log on, so running it as a service, automatically checking for updates, which I would really recommend. And next to that, since I'm running Windows 10, I installed the Windows subsystem for Linux, which means that all the Linux-based containers I'm going to run are technically driven out of that Ubuntu WSL engine. If you're not using it because you're not using Windows 10, or at least not the latest version, it's going to rely on the Hyper-V engine and installing a little Linux-based Docker virtual machine and using that one as a container host. The other important one is the Docker engine. Now I'm running the latest version 20 beta 1, and I need that one for one of my demos later on. And at the same time, it's also running a Kubernetes emulator if you want, where it allows you to build out Docker containers that you're going to host on top of whatever Kubernetes flavor you want to use without installing a full-blown Kubernetes environment. So that's your starting point. From here, you can manage everything from the command prompt. If you install the Microsoft terminal, that works fine. If you want to use it from within a PowerShell window, that's also fine. Or you can go back to the Docker Engine tool, and it's going to show you some history about your containers. So it's not a full management platform from here, but I can see that I have a container, simple commerce. It's my e-commerce example. It's green, which means everything's fine. But for now, I'm going to stop it. And that's going to shut down everything. Or I could select another one, starting it up or deleting because I don't need this anymore. And it's actually something I should do a little bit more often because I do have quite a lot of legacy containers that I'm not really needing anymore. So a couple of basics from here. You can do Docker info, super interesting comment because that's going to validate if your engine is running, all looks fine. I got my Docker images, where an image is, again, that isolated bubble of the application source code, the binaries, but not really an operating system. Now, to speed up the demos a little bit, I already have a couple of containers running here, where the main one I'm going to use is this simple commerce one. Now, where does this come from? It's my web application. And if you're familiar with .NET development, you're going to recognize, so I have a whole set of modules where my modules are technically the intelligence from my application. So I have my shopping cart where I move stuff to the basket. I want to ship information. I want to integrate with different payment options. And I publish my web application, and that's going to become my web shop interface. So this is my Visual Studio environment. The nice thing is when you deploy Docker Desktop together with Visual Studio, it's actually taking away quite a lot of the complexity away from you on how to build and containerize your app. So what you can do is selecting your project, right-click, add Docker support. It's going to ask you, like, what is the baseline you want to use, Linux-based or Windows-based? Now, since my app is .NET Core, I could use Linux. You press OK, and it's creating a Docker file. Now, what is a Docker file? It's some kind of script sequence. And it's technically the hardest part in containerizing apps because it's not really straightforward. Even although in this case, Visual Studio is helping you, it's not always that easy. Now, on the other side, it shouldn't always be super complicated because what you do with compiling an application like this one in .NET is technically running .NET build, .NET publish, .NET run, and that's what we're going to tell the Docker file. So we start with a baseline container. How does Visual Studio know which container to use? It's going to read out your project file. So in my case, it's .NET Core 3.1 out of the app settings files. So it's going to reach out to the Microsoft, lost my cursor here. It's going to reach out to the Microsoft backend, MCR, that's Microsoft Container Registry, where Microsoft offers you a precompiled kernel-alike bubble if you want, that recognizes and allows you to run .NET Core 3.1. From there, we're going to create a new folder /app and telling the container that anything that comes within needs to run on port 80 and 443. Why? Because it's a web application. It's really that easy. Next, we're going to inject our .NET Core SDK. In this case, would be the same for Java apps, Node apps, where you would integrate with Java baseline containers, maybe Node baseline containers. That's the idea. Where next we're going to create a subfolder. So when my Docker file gets compiled into a running Docker image, it's literally starting up this image, injecting some actions in line 4 to 6, starting up a next container baseline, and injecting some other actions. Literally what I'm doing here is copying my source files. So each and every of my application modules are getting injected. I do have quite a lot of them, so It could look complex, but technically it works for just a couple of them as well. Where next I'm going to copy everything from my source folder in my app up here, migrating all the source code into this baseline container. Almost identical to compiling your app, and if you want, creating like a web deploy zip package. Where next we're going to tell the Docker file, execute .NET build. I'm quite sure that some of you .NET developers know what it means. .NET publish, and eventually, that's the most important part, we're going to tell the container, once you start up, once you're becoming a live running container, these are the actions I want you to take, which means you're going to execute .NET starting up my simple commerce application. Nothing harder than that. So from here, if I would debug my app or building it, it's going to execute the Docker file steps. And hopefully it goes a little bit fast. So executing all the steps, this is traditional debugging or app debugging, nothing different than running traditional source code. And somewhere all the way at the end, it's going to produce my Docker image. Come on, just a little bit more. I'll keep it running for now. Good. Now the outcome here is this offline image. So I speed up the process a little bit, and that's the outcome. From here, I could do Docker run interactive, pointing at this one. And that would somehow spin up my workload. Now it's still building in the backend, so it might conflict a little bit, but I'm not too worried about it. Now it's already doing something, it's waiting, so you can see up here that it's waiting, so we can validate using our container list. As you can see, there's quite a lot of like Linux integration, so if you have some background in Linux command line, it's always helpful. But up here, I can see that my container is running. So I could now connect to localhost port 80, and that would show me my workload. Now this is all on my local machine, and up here I get access to my kernel. So I'm actually logged on to that little stripped down .NET Core, and if you want, you could execute some Linux commands from here. Cool. So that's working fine. Oh, I'm still inside my. That's it. That's a little bit on this one. So Docker info, are you actually running? Docker images to validate, and Docker run to start them up. Now from here, we're going to move into our Azure world, where we're going to host our containers. Now Azure Container Registry is the starting point, and that's our library placeholder for Docker containers. So what we can do here is moving our offline image into Azure Container Registry, and from there, it will be the starting point for all the other services. Azure Container Instance, WebApp for containers, and if you want, Azure Kubernetes Service. Where you have a couple of different scenarios, you can deploy basic, that's the cheapest one, it's a little bit slow. The standard, which I would recommend for most production environments, or premium, where premium gives you a lot of backend storage. So if you have a lot of different container versions, because it's in a dev and test scenario, or you have a pretty complex, large environment that you want to containerize, then I would definitely recommend premium. Or another interesting scenario, scared me for a second, but it's just my Visual Studio that did a little bit weird there. The output of compiling my app. So the premium, another scenario it gives you is high availability across different Azure regions, where technically if your application is depending on the registry and for whatever reason you lose the Azure region or you lose the registry, your workload will still be up and running in another region. Now, ACR by itself is obviously supporting Azure and supporting the Docker standard. So it's like a full 100% compatible Docker registry, similar to Docker Hub. That's typically a public one where you can find a whole bunch of sample and vendor containers. Same on AWS, where you have AWS Container Registry. Google Cloud would be the exact same model. So we have the registry within. We're going to build a repository. That's our library, our collection of containers. And from there, we have an offline image where we're going to hand it over to another service, and that's going to run it. So important, Azure Container Registry is not hosting your container itself. It's not running it. Now you can integrate, moving a little bit to like the DevOps way of working. In meantime, you can use Azure Container Registry to automate your process. So imagine that you work on your application workload, you have source control. Every night you're going to publish a new version of the WebApp source code. It means that you're going to compile new containers. So every single day you would go to your Docker environment, running Docker builds, running Docker push, moving it into the container registry. And in meantime, by using ACR tasks, you could automate it. So that's at least something that could help you. So I'm going to switch to my next environment and deploying a container registry. What's important here? I'm using the portal, but you could automate this using Azure templates, Terraform, CLI, PowerShell. Another Azure resource, just like anything else. You specify the name. So we're going to connect to a shared namespace up here. So azure.cr.io. You're going to define the Azure region. Where do you want to create a registry and what is the flavor you want me to use? From there, if you want, you can make it a bit more locked out because it's a public cloud running service. But in meantime, since a lot of customers are migrating to cloud, maybe they want to use containers, they want to use container registry, but they don't want to expose it as a public cloud service. So once you move to the premium flavor, you can activate the private endpoint here. And it means that everything is like almost running in your internal network environment, although it's hosted in public cloud. Some other options around encryption, which allows you obviously to encrypt your data at rest. So whenever you push a container into the registry, container registry is going to recognize it, encrypting it, and that's obviously helpful in the security part. This deployment takes a couple of minutes. Now to speed up the demo a little bit, I already have a registry where the outcome looks similar to this one. So based on the flavor you deploy, it's going to give you storage, it's going to give you some performance, which means if you have a lot of containers you want me to start up, having storage capacity and performance is probably a good thing. Another interesting one that could be familiar for developers in the audience is source control, where you would integrate with security code scanning. So what Aqua and Twistlock, two third-party vendors, were using on top of ACR, what they're going to do is allowing you to run a code scan for everything that's running inside the container. So you're going to push it from your local machine into the registry, and before it gets accepted, it's going to run security code scanning. So identifying any vulnerabilities, outdated NuGet packages, if it's a .NET application, where the recommendation obviously would be move it all the way to your coding process. So you could integrate Aqua into your development cycle out of the Visual Studio Marketplace, for example, or even moving it into like Azure DevOps and injecting it as part of your pipeline. If we do have time, I could actually show how containers integrate with Azure DevOps all the way at the end. Now, this is my registry. Now, from here, it's not really having anything yet. So we're going back to our Docker images. For now, I'm going to move this simple commerce output from Visual Studio into my registry. Now, the first thing I need to do here, I wouldn't call it security as such, but it's actually quite powerful. I need to make sure that my container reflects the name of my container registry. Easy said, if the name is not reflected in the tag in the name of the container image, the registry is not accepting it. To do that, it's Docker tag with the name of the registry you want to use and the name of the container image you want to use. So in my case, it's simple ACR, that's the registry, and simple commerce is my simple e-commerce example, where you would run Docker push, grabbing this name, and it starts uploading. Or maybe not. Why not? Obviously, that's where the through security comes in. My Docker environment, my local Docker engine has no interaction with Azure whatsoever. Although I'm authenticated in the browser and everything, but I need to tell Docker how to recognize my credentials. What you can do is using AZ, that's Azure command line that you first need to install on your local machine. Obviously, running ACR, that's interacting with Azure command line and authenticating to, I'll show you, where you're going to tell the name of the resource group and the name of the registry. So this would be simple ACR and the resource group. I need to check simple C WebApp. I'm already authenticated on Azure, so it will recognize my token. If I'm not authenticated yet, it's going to open the browser and asking you for your credentials. Good. So now I'm authenticated, which means Docker can now interact with ACR, running my push again. It tells you that everything's already there. Why? Obviously, because I want to speed up the demo, because otherwise it needed to push like 400 something megs. That's the size of my application. And I'm not gonna wait for that. Good. So now we're done on our local machine. And the outcome is within my registry, I have my simple commerce repository waiting for a container workload to be used. Where the first one, think back about all the different options we have, is container instance. Now, what is container instance? It allows you to grab a container from the registry, Azure One, public Docker Hub, or any other one that it can reach out to, and starting up your instance. Nothing too hard, nothing too fancy. Literally give me a container and I'm gonna run it. Although it's quite basic, it's still powerful. It runs your container as it should be. It gives you detailed logging from the Docker perspective, but also from the Azure service perspective. Whenever something goes wrong with the instance, it's going to stop running and restarting itself. That's the default behavior. You can integrate with internal network scenarios if you don't want to expose your container to the public world, like running an internal application or running like a Python script to do some risk analysis in machine learning or artificial intelligence examples, where you don't want to expose anything to the public world. Know that you can do that. Two different options. So, or you're going to trigger an ACI build from here, where it's going to ask you a name. So this could be the VISUG ACI 1. Is your operating system in the backend? So that would be your Docker host again. Where do you want to run it in your subscription resource group? All basic Azure scenarios. Location, I'm selecting West Europe. Now, technically, my registry runs in Europe. It's an Azure service, which means you can connect to it from all over the place. Now, one of the characteristics with containers is that they start up quite fast, where now if I have my registry, like my baseline library of images in West Europe, and the instance itself is going to run in East US, West US, somewhere Australia or APAC, it's obviously going to take a while before the 500 meg image ends up in the other region. But technically, it's not limited to hosting containers in the same region. I can specify some compute power, one CPU all the way up to 8, and I can define memory. So I could move to 4 gigs, for example, to speed it up a little bit. And just for the fun of it, I want to expose it to the public. You already know it's a web app, so I'm going to use port 80. While this is running, let me quickly check if there's Q&A. Nothing. Way cool. That means that or everything is super clear, or you're having dinner right now because I teased you with soup and you're like, oh my God, I'm starving. So this is going to run for a couple of minutes, typically like less than 2 minutes, and giving me my workload. Now, there's quite a lot of interaction. I would say you need to know ACI, you need to know Azure. I could do the same demo using Cloud Shell or PowerShell, but since only a few weeks, there's something new where Docker released that updated version. Remember, I'm running version 20 beta. And what it gives you is direct integration from the Docker command line into Azure Container Instance. You have Docker, so it's already running. You don't need to do anything from there. And what we're going to do is creating a context. Now, what is a context? It's like a local environment where I'm currently running the default. It's everything on my local machine. And I can create a second one where I'm going to interact with ACI. That's the main goal. And obviously, I'm going to try and show you. Well, let's see how far ACI is. It's still deploying. It succeeded. Let's quickly check what's running behind it. So first, a little bit of logging so I can manage my container environment. So up here, it's running a pooling statement. So it's connecting from ACI into ACR. Takes a little bit of time. The pooling is successful, which now means that my container runtime, my host, accepted the container image, copied it over from the registry, turning it into a running container and starting it. And it's running. Since I defined public, I have public IP address. That's an interesting one. We could use a .0, so let's see what happens. Homepage, that's promising. So I have my web app and I can connect to my database. How does it know how to reach the database? It's not a best practice, but easy in my demo scenario here. In my app settings file, in my Visual Studio, in my app settings .json, I have a hard-coded database connection string to SQL Azure. And since it's Azure ACI connecting to another Azure service, they trust each other and everything's working out fine. From here, yes, it is a full running application. So I could select anyone interested in a phone, want to pay for it. It's maybe a bit too expensive, although Apple could be quite expensive, but not that important. I could move stuff into a basket and logging on from here, throwing in my credit card and paying for it, which probably might be a problem on my credit card, but that's not really part of the demo, but it works fine. So back to that new Docker integration. Again, it's all in beta for now. So you need to have the latest Docker engine there. And the first thing we need is, again, authenticating Docker to connect to Azure, where before it was AZ login, where now that authentication is coming from the Docker command line. This is cache credentials in my browser since I'm already authenticated in the portal, and a little bit of inception there. I'm successfully logged in. So I can do Docker context test, and I have two of them. One is a test that I ran. Worst case, if I need to go back because the live demo is not working, I have a fallback scenario. But my default for now is Moby. That's the name of the Docker virtual engine on my local machine. So from here, we're going to create a new one. It's Docker context create ACI and some name. Let's call it the VisugXL ACI. There we go. This is starting a little wizard. It's recognizing my credentials. It's showing me different subscriptions. It assumes that I'm going to use the first one. So just enter using an existing resource group or a new one. Let's do a new one. And it's done. That was quite easy, right? So let's see what happened. I go to my resource groups. And where's the VISUG? There's no VISUG, so we're going to refresh. And there's nothing visible for now. Let's check back. So what happened is it created a resource group with some interesting name, like a GUID almost, and created in East US. Well, that's all cool, but technically I'm not in East US. So what you can do, I'm not going to show you, but what you can do here is Docker context create ACI. That's the integration. And the West Europe VisugXL ACI, actually we can do this. For now you can define location West Europe. That's the name of the Azure region. The resource group name West Europe. You see, still pinging for my subscription, although I could add -- subscription and adding that one. And probably some typo, but you probably get the point. Where next I need to identify that I want to use that specific context. So I'm going to do Docker context use. I'm bad in memorizing command line. Demo ACI. Cool. And from here, I can do Docker run port 80 to 80. That's my internal container port mapping to the public facing port and the name of my container, which is this one. What this is going to do is grabbing my container, not from my local machine. To be clear, this is a copy I have in the public Docker Hub. If you want, you could again extend the command and adding -- registry and then pointing to the name of my Azure Container registry. But what's happening here is that now my resource group should be there. So let's do another refresh. There we go. There's a little GUID. And in there, it's going to spin up a container instance again. 100% the same as what I did earlier, but this time all managed from within the Docker instance. Cool, 15 minutes, nice. The other option, remember in that overview, is WebApp for containers. I assume that you're hopefully familiar with web apps. So what is web apps on Azure? It's a hosting environment, platform as a service, no virtual machines, where typically you would push out source code. Any language, .NET Core, .NET, PHP, Ruby, Python, Golang is also in there, although it's not showing up in the list, but it is supported. And you typically would push out your code. Where now you're going to do the exact same thing. About 90% of web app for container capability features are now brought in and hosting your container workloads. Couple of nice integrations here. So web apps are more high available than Azure Container Instance. So if you have a more business critical or business important workload, You might go for ACI for testing, like, is my app running or not? And once it runs, let's move it into a more production-ready state on top of web apps. It has built-in backup where it's going to capture all the configuration options that you define for web apps, but it's not creating a backup of the container image. Or moving to Docker Compose, where again, it's that integration between different Docker containers, one for the web front end, maybe a database container, or like a Nginx is a popular one on Linux as some kind of proxy, reverse proxy, to protect your web workload. And in short, it's literally everything that you know from web apps, where instead of pushing code, you're going to push out your Docker container. And yes, no surprise there, another demo. I love it when live demos are working. So maybe I jinxed it now. Let's hope not. So let's deploy a web app. And yeah, why not in the fluffy resource group? The VisugXL, it's not ACI, Peter, it's web app for containers, or let's do another acronym from the soup, web app for containers. There we go. It's unique. Bring in the Docker container running on Linux in West Europe to speed it up a little bit. I need an app service plan where it's defining cost and features. And next, I'm going to move to my container settings. Running single container or Docker Compose. Don't worry too much about preview. It's been in preview for, I think, more than a year and actually running perfectly fine. Out of web apps, although it runs on Azure, we can run a quick start. That's like a hello world demo, so nothing super excited there. My internal own Azure registry, the Docker Hub, or any other registry you have. This could be AWS registry, on-prem registry, Google Cloud, any other cloud registry. As long as you have the URL, the credentials, Azure Web Apps can spin it up. Same scenario and running it. And that's spinning up. Cool. Now, if all goes fine, I should already have a container app up and running. It's the exact same thing. It's just speeding up a little bit in the process. But again, just to show you, it's a full-blown web app. It has a URL. I have the full web app monitoring. I can store app configuration settings where I already have a couple of them for my Docker registry. I could add my database connection string, although again, in my setup, it's part of my container source code, which would not be a best practice in a full production environment. I can validate my container settings and I can see a full detailed trace. Remember in ACI, it was only showing pooling, pushing. Where now up here, I can see the full stack. And all the way at the end, I can see that it's literally kicking off the exact same command that I was running on my local machine. Locking down network settings, moving up to a larger plan, and everything else that we have from web apps. I could use some Kudu troubleshooting tool integration if you do have the permissions to do that, where I could connect to my backend. Oh. And troubleshooting if needed. And let's do a quick check. There's my e-commerce and it's up and running. Way cool. No questions yet, that's fine. We're almost there. So last one is more, I would say, orchestration-alike scenarios. Imagine that you're running this e-commerce example and all of a sudden COVID happens overnight, which pretty much happened actually a few months ago. And instead of having 100 users per day coming to my web app, all of a sudden I have like 1,000 or maybe 3,000, 5,000, or even a couple of tens of thousands. So what I could use is some kind of auto-scaling mechanism, or I need integrated load balancing, where now for my web apps, I could still deploy Azure load balancers. I could deploy application gateway, Azure front door, alike scenarios, but it's an additional service. Or maybe if I have new containers coming in and anything else that I'm looking for, like a full-blown management operation system, that could, for example, move me to Kubernetes. Again, Kubernetes is not a Microsoft product, but we heavily embraced it. And the architecture looks a little bit like this. Now, what we have here is, don't know if I can draw on this. Yeah, looks like it. Way cool. So what we have is what we call the Kubernetes main node up here. That's where all the engine information lives. I call it the Kubernetes brain. That's where it's going to identify the health of the system. It's going to identify the different worker nodes. It's going to identify how healthy your containers are running. It's managing the internal network within your Kubernetes cluster. And from there, you have worker nodes. Now, technically, a worker node is almost invisible virtual machine in Azure. And if you want, I can actually show you what it looks like. But it's based on top of a virtual machine environment with virtual networking, with storage, everything. It's deployed as a scale set out of the box, which means that whenever demand comes in, I could easily add more worker nodes, like more virtual machine compute power, but you don't have to worry about anything of that. It's Kubernetes taking care of that. And then last, we're going to push out our Docker containers from anywhere, in this case, from Container Registry, and managing using kubelet, that's like internal Kubernetes information, and the kube proxy, that's our Kubernetes built-in network stack. On the outside, we have full integration, so you can manage, deploy AKS as another Azure resource, providing internal networking, public-facing networking. If you're more into infrastructure as code, you have ARM templates, Terraform, or anything else you want to use. Start small with a single node. In my demo setup, I got 2 of them, and pushing out your container images. If you're into developing or using a DevOps mode, you can do the exact same thing, where the first part is what you typically see from the developer side, integrating with everything in Azure using CI/CD pipelines out of Azure DevOps or Jenkins or another DevOps tool, still moving your Docker image into Container Registry, which by itself could be done out of Azure DevOps pipelines, for example, in the build state, and running your containers. In a larger environment, you're probably going to move to a Kubernetes extension that's called Helm and Helm charts. It's like a configuration template files to speed up the interaction between pick up my container from here and move it into the cluster. I don't have Helm running, but I can show you the manual integration. And then last, you have the AKS control plane, which means that once AKS is running, it's a full-blown Azure service, although it's Kubernetes running the non-Microsoft product. But what we did is almost fully Azureizing it, which means if you're familiar with Azure Monitor, Azure Logging, Azure Alerts, anything else, it's all valid for AKS as well. Out of Kubernetes itself, there's a dashboard tooling out of Kubernetes native dashboarding. You could integrate with Prometheus, you could integrate with Grafana, some other popular dashboarding tools. Even running on AKS would be 100% supported to still do that. Where again, out of Kubernetes, it's a typical scenario where you're going to run Kubernetes in different environments, and we're heavily embracing and supporting it. So how do you get your container from your local machine or from the registry into your environment? So, or you're going to use Helm charts, or you're going to use a combination of Visual Studio Code to alter your YAML file you're going to use kube control. That's the Kubernetes command line option, allowing you to interact with your environment or managing everything from within the Azure portal. So the last demo for tonight, in the last few minutes that I have left, so I deployed my AKS environment. Where I can start monitoring it. So I have my node pool. It's running Kubernetes 6.15. I can easily upgrade to a newer version, which I'm not going to try in the last few minutes of my demo. But what it does, and that's again Kubernetes intelligence, it's going to spin up new nodes with a new version of Kubernetes, migrating the containers, which Kubernetes calls pods. And when everything's successful out of the main node, like the brain, it's going to tell the old nodes, like, fine, I have 2 new ones, everything's up and running, and you can shut down and be removed from the cluster. So that's what Kubernetes calls rolling upgrades. I can define scaling, where now I'm running 2 virtual machines, DS2, so small ones, because I don't need a lot of compute power for my demos. If I want, I can easily move up to a couple of hundred, where unfortunately in my subscription, I can only move to 49, and then I'm most probably running out of budget. But it's quite powerful. Good. The other component is the Kubernetes YAML file, which I cannot see for the moment. Where did I store it? Nowhere to be found. Let's go back to our backup repo. It's called GitHub. We might have a sample file to show you. Looks like a lot of traffic on GitHub. It's a bit slower than usual. There we go. So in here, you define the name of the application runtime. That happens here, and the name is coming back in a couple of different places for metadata. You can, for example, specify high availability within the cluster. So in my case, replica 5 means within the Kubernetes environment, spin up 5 identical instances, and the load balancing in front of Kubernetes is going to present it as one single workload. The image I'm going to use is defined here, almost identical to all my previous demos. Grab this simple one from the ACR and expose it on port 80, similar to what I did with ACI and WebApp for containers. And last, a bit more down, expose this workload behind a load balancer. From there, you would use kube control apply, pointing to the YAML file, and that's going to push it out into your Kubernetes environment. Again, you can use the Kubernetes built-in dashboarding. I'm showing you the new preview management, integrated management tool from the Azure portal. So I have my namespace, so the default is my cluster, and within I'm running different workloads. So each and one of these are running application workloads, where actually most of them are built-in system containers, which is actually quite interesting, where Kubernetes as the platform is relying on itself to actually run healthy. So all kube system, that's internal Kubernetes services and engines. So my applications are running here, where I have my container app, 5 instances, because that's what I defined in my YAML file. And from here, I can see they're running, been running for a while. And each and every pod, like a standalone container instance within the cluster, receives its own IP address. I can validate some configuration if you want to build up like a CMDB if you want, or just validating settings. Up here, I can see that I have my 5 replicas. This is the image I'm using, and this is the name for this application bubble. where, if all goes fine, I should be able to see services. And again, this is all Azure portal. What we're doing is literally taking away the complexity from the kube control command line. It would be kube control get pods, kube control get services. We're now public IP address. Fingers crossed, last demo for the day, and the web app is running. And still connecting to my SQL database because it's a trusted Azure service. There we go. Way cool. So with that, I'm finished. So for the last minute here, would like to thank you. What we talked about is what are containers, why using them, journey to the cloud, how to create them locally using the Docker engine, Docker daemon, how to run them on Azure, ACI standalone, web app for containers, or the AKS orchestration. Feel free to reach out. I'm all over the place. Email could be useful. If you want to stay in touch on Twitter, that's perfectly fine. And one last check for any questions. No questions at all.
Hi, Peter.
So
No, indeed, I was checking the chat, and we don't have any questions at this point in time. So, yeah, people could contact you afterwards through Twitter or some other way of contact.
Definitely true. Yeah. No issues there.
Thank you very much, Peter. Very interesting session. And yeah, let's keep in touch.
Thank you for having me, and enjoy the rest of the conference.
Excellent.
Thank you.
Bye-bye, everyone.